We use the distance formula to find a distance between 2 points. Okay? So, I'm sure all of you are wondering, what is the distance formula? The distance formula is the square root of the change of x squared plus the change of y squared.
What is that?
The distance formula.
No, but what is that?
All right, well, we're going to talk about it. Okay? So the distance formula is the square root of the change of x's squared plus the change of y squared. Let's first talk about what our x and y's are. So if I have a point, let's say 2, 1, which one of those is my x value? 2, right? And so 1 would be my y, right? So whenever you graph a point, that's your ordered pair, x, y. And this is the x and y that we plug into our equation. Okay? So this would be considered 1 point. The distance formula is used to find the distance between 2 points. So if we want to try 2 different points, that's what we do. Okay? So we can write this out a little bit different way, give it a little different look. This triangle right here means change of. It's just one of the ways. So this is the same as saying x2 minus x1 squared plus y2 minus y1 squared. Okay, that y2 and y1, or x2 and x1, that just means that they're the 2 different x values in the points. Okay, so like x2 would be 2 in this case, x1 would be 1 in this case. So my 2 x values that we have. So my x2 value would be like 2 in this case, and my x1 value would be 1. It's saying we use the x values from both our ordered pairs, but they're going to be different. Okay? It's important to know when you start here, the change of x and the change of y, that means you're subtracting the values. So you're subtracting your x values and you're subtracting your y values. Okay, so let's go ahead and let's try this example. So if I have d, my distance, equals the square root, so what would my x2 be if I'm using these 2 points right here? 2 minus 1 squared plus, what is my y value? 1. Now, it's important to know, if you use this ordered pair for the first one, you have to use that ordered pair for this first one. So if you use the 2 for this x2, you have to use the same y2 here. So let's simplify this. What's 2 minus 1? 1 squared plus, what's 1 minus 3? Not just 2. Negative 2 squared. Okay? 1 squared is? What's 2 squared? What's 2 squared? 4. 2 squared. Huh? 2 minus 1 is 1 squared. 1 minus 3 is negative 2 squared. So I have 1 plus 4, so I have the square root of 5. Can this be simplified? No. So my answer is just the square root of 5. 2 squared is 4. Yes.
I did it differently. I squared it right after I added minus them, like 2 minus 1 squared. And
That's fine.
And I got
Yep.
the same answer.
Yep, that's fine. I just wrote out one more step than you did, so that's fine. Okay, let's do another one. Okay, I want you guys to do the points 6, 5, 6, negative 5, sorry, and negative 2, negative 7. Okay, what is my distance formula? square root of, you all have it right in front of you. What's this? X. I'm just writing my distance formula. Y2 minus Y1 squared.
Oh, I got it now.
Okay, distance formula. D equals the square root of x to the 2 minus x1 squared plus y2 minus y1 squared. Okay, so I'm going to look at my points right here. I'm going to say this is going to be my x1, so this has to be my y1. This is going to be my x2, so this has to be my y2. Okay, so D equals the square root of, what is my x2 value? Negative 2 minus my x1 value squared plus, what is my y2 value? No. Negative 7 minus, what is my y1 value? Negative 5. Yeah. Why did you use negative 6? It's just positive 6.
It's just minus 6. No, I put 6 instead of 2.
Yeah, he's saying he put the 6 in front of the 2.
Yeah.
Okay, well then your negative 5 should be in front of the negative 7. That's fine. You can do it that way. I just labeled it this way, so we're going to stick with that way. Okay, so how would this simplify? Negative 2 minus 6. What is that? We'll get there. Let's do this one first. What's negative 2 minus 6? Negative 2 minus 6. Negative 2 plus a negative 6 is negative 8 squared plus, we're just simplifying, negative 2 plus negative 6. What's negative 2 plus negative 6?
I just kept the 6 and 5.
What is, everybody, what is negative 2 plus negative 6?
Negative 8.
Good. That's what I wrote here, squared. Okay? What is negative 7 minus a negative 5? Negative 2 squared. It's negative 2 minus 6, so I changed it.
So it's a negative 6.
Okay? So, D equals the square root of negative 8 squared is 64. What's 2 squared? 2 squared is?
Oh, yeah.
4. So I need the distance of the square root of 64 plus 4 is 68. Can that simplify?
No.
There's no perfect square can go in there? What is 4 can't go in it?
Yeah, 17.
Divided by, do 68 divided by 4.
It's 17.
So my distance is the square root of 68, and I can simplify this. So this is just like our simplifying radicals now. This can break into the perfect square of 4 times the square root of 17. Square root of 4 is 2. So I have 2 square roots of 17 for my distance.
Great.
So we're adding this with that, and
Okay, we'll do another example. Okay. 5, 9, and 12, 18. Okay. I want to find the distance between these 2 points. So I'm just going to say this is my x1, this is my y1. So this is my x2, this is my y2.
so do we just put them there as positives?
For what?
For like in the formula?
No. Well, these are all positive, so then it would be yeah. So my distance formula is x2 minus x1, or the change in x's squared, plus y2 minus y1, or the change of y squared. So now that I labeled what each of these points are, I just plug them in. The distance equals the square root of, what's my x2? 12 minus my x1 is 5 squared plus, what is my y2? Minus my y1 squared. Okay, so my distance equals the square root of 12 minus 5 is squared plus 18 minus 9 is 9. And then we have that squared.
49
So my distance equals the square root of 7 squared is 49 plus 9 squared is 81. So my distance is going to equal the square root of 49 plus 81 is?
130.
Good. Can 130 be simplified at all? Is there a perfect square that can go into 130?
No, I got 32.5. And I divided it by 4.
Okay. Check the other ones. What? 26 times what? Okay, so 26, is 26 a perfect square?
No.
Is 5 a perfect square?
No.
Nope. Nothing can go into it, okay? So, the distance is just the square root of 130. Sometimes they won't be able to simplify, but you need to check. Okay, let's do one more example.
No, I wasn't done.
How do you go back?
On the right.
Oh, right here. Okay? All right. 2, -5, 6, -7. What is my distance formula? Square root of x2 minus x1 squared. Good. My change in x squared plus my change in y squared. So I'm going to label it on top again. This is my x1, so this has to be my y1. This is my x2, so this has to be my y2.
Oh, geez.
Plug it in. What is my x2? What is my x2? 6 minus 2 squared plus -7 minus -5 squared.
Minus -5.
Mm-hmm. 6 minus 2 is 4 squared. -7 plus a 5 is -2 squared. So my distance is 4 squared, which is 16 plus 4, -2 squared is
Plus 4.
4. So my distance is the square root of 16 plus 4, which is 20. Can 20 be simplified?
Yes.
What perfect square can go into 20?
4 and 5.
4 and 5. The square root of 4 and the square root of 5. Good. 4 square root of the square root of 4 simplifies to 2. We're left with 2 square roots of 5. That's what the difference means. Or the change in. Okay? Your assignment is on page 654, numbers 1 through 6. They're going to give you 2 points. You need to find the distance of them. So make sure you have the distance formula written down somewhere so you know what it is.